Hello friends, I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about basic engineering package. Basic engineering packages. It defines the purpose, content and structure of a basic engineering package or design specification, and its place in the project development process. It emphasizes the importance of carefully maintaining the project's technical direction as defined in the basic design phase and of providing definitive direction and sufficient detail to ensure orderly and efficient progression of subsequent detailed engineering, procurement and construction activities. A typical basic engineering package for vegetable oil refining. Process description. General, N/S. India Limited, intends to put up soft and tropical oil refining project at Mumbai, in India. This plant will produce 1,000 tons of refined oil from crude oils imported from abroad. 3 types of crude oils will be imported: degummed soybean oil, FNO crude olive oil, and crude palm oil peel. FNO means chemical refining without oil, and peel can be treated by physical refining. After refining, all the oils undergo bleaching and deodorizing. Deodorized RBD oils are the finished product.
These are packed in pouches then sent out in road tankers or rail tankers. Part of deodorized peel, RBD peel, and bleached SBO, RBSBO is hydrogenated and deodorized again. Packs of hydrogenated oils are subjected to controlled cooling in cold rooms.
Storage of oils is provided at 5 stages of the treatment process. Crude oil storage, refined and bleached oil storage, intermediate product, refined, bleached, and deodorized oils storage, finished product, hydrogenated RB oil storage, intermediate product, hydrogenated RBD oil storage, finished product. Crude FBO treatment process. Stage 1. Chemical refining of the SBO involves neutralization with caustic soda and washing with water. This is followed by bleaching with clay as adsorbent. Neutralizer and bleacher are the proprietary packages supplied by some companies specialized in this line on turnkey basis. The process is continuous. The utilities required for the plant are low, medium and high pressure steam, soft water, cooling water, nitrogen, hydrogen and instrument air. All facilities will not be provided from the beginning. Initial work which forms phase I will include treatment facilities for soft oils RBDSBO, RBDOL, RBDPO. Hydrogenation section will be introduced later in phase II. However, the EP should consider both the phases and costs of phase I and phase II should be separately indicated. Plant capacity. Oil refining and deodorization are continuous processes without hydrogenation is a batch process. All the plants shall run continuously for 24 hours a day, 7 days a week and 330 days per year. Plant capacity will be 1,000 tons per day of all oils. The breakup is as follows. Deodorizer is common for all oils and is sized to treat 1,000 tons per day. Pre-treatment and blending equipment are common for propylene and palm oil and are sized for 500 tons per day. Neutralization, bleaching, hydrogenation, deodorization are proprietary oil treatment processes. These will be bought as packaged on turnkey basis. Capacities of various storage tank spaces for oil storage at various stages is as follows. packing lines. Pouches. Pack size will be half liter and 1 liter. Total 10 lines size for 50 tons per day. Each should be designed. Out of these, only 4 will be put up in Phase 1 and 6 in Phase 2. Tons. Pack size to be considered is 15 kilograms total. 3 lines size for 50 tons per day. Each should be designed. All of these will be installed in Phase 2. Bulk loading. 2 bays for tanker loading should be considered for Phase 1, which is sufficient for Phase 2 also. 1 rail car loading station near plant boundary to be considered. Warehousing. 5 days storage with respect to packing line capacity should be considered for all types of packs. Storage basis for packaging materials shall be as follows. Major utilities required are raw water at a pressure of 3 kilograms per square centimeter gauge and at ambient temperature. Nitrogen at a pressure of 5 kilograms per square centimeter gauge and at a temperature of 40 degrees centigrade. Purity should be 99.9%. Salt water at a pressure of 3 kilograms per square centimeter gauge and at a temperature of 30 degrees centigrade, having hardness less than 5 parts per million. Dirty cooling water at a pressure of 3 kilograms per square centimeter gauge and at a temperature of 32 degrees centigrade, and wet temperature of 28 degrees centigrade. Cooling water at a pressure of 3 kilograms per square centimeter gauge and at a temperature 32 degrees centigrade, and wet bulb temperature of 28 degrees centigrade. Low pressure steam at a pressure of 3 kilograms per square centimeter gauge and at a temperature 138 degrees centigrade. Medium pressure steam at a pressure of 9 kilograms per square centimeter gauge and at a temperature of 180 degrees centigrade. That steam generation pressure of 10.5 kilograms per square centimeter gauge. Instrument air at a pressure of 7 kilograms per square centimeter gauge and at an outlet temperature of 40 degrees centigrade maximum after dryer. Dew point at 1 atmosphere pressure should be minus 40 degrees centigrade. These are required in different plants for different equipment. The requirement for each equipment for each utility should be calculated in the form of table below in different sheets. These are then added for the individual plants. When requirement for each plant is worked body is added to get the total requirement. Equipment average flow needs to be calculated for feed pump, preheater, phosphoric acid tank, phosphoric acid pump, mixing tank setter, discharge pump, separator. Documents prepared are process description, plant capacity, plant facilities required, utilities summary sheets, data sheets for all the equipment, process flow diagrams and process and instrumentation diagram. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.